Hello everyone, welcome. This is Steve Suffoletto from Erie Community College, south of Buffalo, New York. In my Lithopress 3 advanced class, we're running the Ryobi 3302 press. It's the M model. We also have a C model. It's a two-color press, but it has a register table with a push side guide. I wanted my students to compare the register consistency versus the Ryobi 2800, which is a direct feed that has no side guide. So we took 30 consecutive sheets in a row. We shingled them out. And this is a second pass. The first pass was a cyan, and the second pass was a black. And you can see that the registration consistency here is excellent. They're almost perfectly, exactly superimposed on top of each other. Then we made some adjustments to the side guide, either over side guide or under side guide. And we also made some adjustments to the register table with the drive wheels or the skid wheels on the drive tapes. And then we looked at those results. Here are the results of severe side guide bouncing. You can see on the first pass the cyan is pretty good, but on the second pass black, when we made the adjustments, the side guide bouncing is all over the place. So this is bad. And then tried to optimize the side guide, and we ran 30 consecutive sheets, and this is the results we had. So here's a blow up of that. So I categorized the amount of misregistration by using word adjectives. If the two register marks, which are about 5 thousandths each, are on top of each other or not separated by a gap, I would call that good register. This is fair register. Poor register, I can see a gap, a white gap space between, and then bad is a more severe case of that. So when I photograph this plastic ruler with 1 inch, I can use some type of measuring tool, either like in Photoshop or on a smartphone with a app to measure distances. We can actually measure these distances. So if there's ever a white gap between the first pass and the second pass, I would count that as a defect. So I have a summary table here that shows you the test conditions. OB is the operator side or the button side. GD is the gear side or the drive side. And SG is the side guide. So I had 7 students in my class. Each ran 10 sheets. We pulled all 70 sheets out and looked at them. There was no in-feed bounce on the operator side or the gear side, but there was 18 of the 30 sheets, so more than half, had a white gap in the side guide bounce. So that tells me that we were not optimized in our register table adjustments and settings. Then we ran the press at slow speed, 3,000 sheets per hour, medium speed, 7,000 sheets per hour, and the maximum fastest speed at 10,000 sheets per hour. And we only had 2 sheets with an in-feed bounce on the operator side, no sheets with a bounce on the gear side. But at the fastest speed, 17 of the 30 sheets, again, more than half, had a white gap space between the side guide registration. As you would expect, the skid wheel or the drive wheel not on the sheet, too far off the back of the sheet, did show some in-feed bouncing and also side guide bouncing. And then we made adjustments to the side guide where we under-guided and we over-guided. And again, of the 30 sheets, 27, or almost all of them, had a white gap space. So we did not have very good register consistency. So then we made some measurements. Of the 30 consecutive samples, the minimum width I could measure was 5 mils, so that tells me that's the width of the register mark. The maximum or the worst was 12 mils. The average was 7.5 mils, and a single standard deviation or sigma, which consists of 68% or 2/3, was 2 mils. So that tells me that within plus or minus 3 standard deviations, sigma, which is 99.7% of the population, our registration is within 6 mils, plus or minus 6 mils. So that means if you're going to do pre-press trapping, you have to have at least 6 mils for a good pre-press trap to accommodate and compensate for the press misregistration. Okay, talk to you soon. Have a good day. Bye now.